Welcome to Siddhartha Institute of Science and Technology, Puttur. Myself, Lakshman Sudheer, working as Assistant Professor in EC Department. Today, I would like to tell about electronic measurements and instrumentation. So, in that, we are discussing the first concept, performance characteristics of an instrument. So, what is the performance characteristics of instrument? So, if you can take one particular instrument, how that performance will be decided. So, that performance is decided by two characteristics. So one is static characteristics and another one is dynamic characteristic. So what is the minute difference between static and dynamic? So static means constant and dynamic means changes. So coming to the definitions of static and dynamic characteristics. So the first one, static characteristics. So the static characteristics is nothing but it is defined as a set of criteria defined for the instruments which are used to measure the quantities which are slowly varying with the time or mostly constant. That is called as static characteristics. And coming to the dynamic characteristics, it is defined as the set of criteria which are varying with such dynamic differential equations is called dynamic characteristics. So these are the two definitions of static characteristics and dynamic characteristics. So coming to the static characteristics. The static characteristics are of various types. So in that, the first one is accuracy, precision, resolution, sensitivity, static and dynamic calibration, errors in measurement, and statistical analysis. So these are the various static characteristics. So what are the static characteristics means? Accuracy, precision, resolution, sensitivity, static and dynamic calibration, errors in measurement, and the statistical analysis. So coming to the dynamic characteristics. So the dynamic characteristics are also various types. One is speed of response, fidelity, lag, and dynamic error. So now we can discuss about each and every characteristics one by one. Coming to the first one. So what is the first characteristics? Accuracy. So what is the general meaning of accuracy? So the general meaning of accuracy is accurate, exact value. So now according to the definition, it is defined as the degree of closeness with which the instrument reading approaches the true value of the quantity to be measured. That is called as accuracy. So it is defined as the degree of closeness with which the instrument reading approaches the true value of the quantity to be measured is called accuracy. And it is denoted by capital A. So for example, if you can take the silicon diode. So what is the cut-in voltage of silicon diode? 0.6 volts. And similarly the germanium 0.3 volts. So that means exact value is 0.6 volts. So that is the accurate value. And coming to the resolution. So what is meant by resolution? So the resolution is nothing but a small change in the measurement variable is called resolution. So that means if a non-zero input quantity is slowly increased, but the output does not changes until some minimum change in the input takes place. That minimum change is called as resolution. So simply we can say that the smallest change in a measurement variable to which an instrument will respond. So that is called as resolution. And coming to the precision. So the precision is nothing but it is a measure of consistency or repeatability. So what is that? Measure of consistency or repeatability. So according to the precision, it can be divided into two types. One is conformity and second one is significant figures. So what is the conformity and what is the significant figures? So conformity means, suppose if you can take one resistor value calculated by using ohm meter or multimeter or by using the color coding. Suppose if the resistor value is 2, 3, 5, 8, 6, 7, some ohms. So when you are pronouncing that value, it will be little bit difficult because it is a more than 3 values. So that's why it's a little bit difficult to pronounce that resistance value. So that value we have to convert it into human readable form. So that is either kilo ohms or mega ohms or milli ohms or micro ohms. So that is the conformity. So that means conform value. And coming to the significant figures. So the significant figures is nothing but it convey the actual information about the magnitude. So what is that significant figures? It convey the actual information about the magnitude. The significant figures is nothing but before value and after value of each and every measurement. For example, if you can take 110 ohms. So that 110 ohms we can call as 109.9 ohms or 110.1 ohm. So that is the significant figures. So each and every value having the three significant figures. And similarly, from that significant figures, we can calculate the precision by using the mathematical equation. So that mathematical equation is nothing but precision P is equal to 1 minus modulus of xn minus xn bar whole divided by xn bar. So where xn represents nth value of measurement and xn bar represents average value of measurements. So that how we can calculate that average value of measurements xn bar. So that xn bar is equal to the sum of total readings divided by number of readings. That is a xn bar. So what is that modulus indicates? So the modulus means if we are getting the negative value, we can consider it as positive. So that is called as modulus indication. And coming to the sensitivity. So the sensitivity is nothing but simply we can call as the ratio between change in output to change in input. So that is the ratio of change in the output. That means response. Because of what? Why? Because if I are giving one input to one system, so it simultaneously it get the output according to the input. So that is called as response. So the ratio of change in output of instrument to a change of input are measured variable. So change in output to change in input. So the representation is delta Q naught by delta Qi. So the delta represents in the mathematical change. So that is the sensitivity. And sensitivity is indicated by capital S. So S is equal to delta Q naught by delta Qi or change in output by change in input. And similarly, the units of sensitivity are in three types or three notations. So one is millimeter per microamperes or millimeter per ohm or count per volt, etc. So these are the three units we can express in the sensitivity. And coming to the error. So what is meant by error? So the error is generally difference between true value and measured value. So that is nothing but the deviation of the true value from expected value. So it is defined as the difference between true value and measured value, or it is defined as the algebraic difference between the true value and measured value is called error. And coming to the calibration. So in that calibration is nothing but it is a process of making an adjustment. So simply we can call as process of making an adjustment. So why we have to do that adjustment? So for example, if you are doing one experiment, suppose one value is slightly changes. So that adjustment we have to do. That is called as for the constant. That means for example, 0.3, 0.2, 0.1, like that it will be blinking. So for that clear adjustment we have to do for the exact value, that is called as calibration. It is a process of making an adjustment. So why we have to do that adjustment means marking a scale so that the readings of an instrument agree with the accepted and certified standard. So that is the main process for the calibration. And this calibration having so many procedures are there. So one is primary standard and secondary standard and visual inspection. So these are the calibration procedures. And the calibration also can be divided into two types. One is static calibration and second one is dynamic calibration. So the static calibration is nothing but it is defined as the calibration which vary with or which does not vary with time constant. That is called as static calibration. And coming to the dynamic calibration. So the dynamic calibration is nothing but it is defined as where the calibration varies with the differential equations or time constant is called as dynamic calibration. So static calibration and dynamic calibration. And coming to the errors in measurement. So before that, what is that? What are the errors in measurement? So according to the errors in measurement, it is a process of comparing an unknown quantity with an accepted standard quantity. Just we are comparing with unknown quantity with known quantity. That is the measurement. So when we are comparing those two, if errors occur, that is called as error. Simply, that means it is defined as the algebraic difference between the true value and measured value. So that error can be divided into so many types. So that is errors in measurement. So what are the factors occurring the errors in that measurement? So that errors in measurement is one is